Is it 954 and then round it by half?
Perfect. Usually my math lab will say give it to me till 4 decimal places. So if they want it as a decimal, they'll say give it to me as 4 places behind the decimal.
So it's the last number that we rounded up.
Correct. The last number is the one.
That's what confused me.
The last number is the one that needs to be rounded up.
I thought it was the third one.
Nope. So if it's to 4 decimal places, you are rounding the 4th decimal place. Cool?
Yes.
Alright. Ready a chance to get caught up on that one. Alright, this page is O. Let me show you I'm just going to show you the formula sheet. On your final exam, I do give you a formula sheet because some of the stuff on the formula sheet you will need. On the formula sheet, the last 2 pages of the formula, or the last 3 pages of the formula sheet, there are, it's basically 2 tables, but it looks like 3 tables. This is what I call the easy table because it's on 1 sheet of paper. The last 2 pages are what I call the hard table, only because they put it on 2 pages, because it's a little more detailed. So I'm going to go through and show you what the table is, just so that you kind of understand it. The easy table is, it's going to give you the z-score, which we just talked about. The z-score is the number of jumps. So if I tell you that the z-score is 1.1, for example, so my z-score, let's say, is a 1.1. That means if my z-score or my standard score is a 1.1, that means that my percent under the curve is 86.43. Now, you've got to realize, but y'all are never going to use this, that the table represents the values to the left. So it's like Beyonce. To the left, to the left, to the left. So this table only gives you to the left. So if I gave you a table like this and I gave you a z-score of 1.1 and I wanted to know the shading to the right, it would give me that this is 86.43%. Well, that's not the part I want to know. I want to know the other part.
100%.
So I would have to do 100%, which is the whole thing, minus the 86.43%, because the table only gives me to the left. Okay? So that's a little bit about the easy table. Now, the harder table, and again, it's not that it's hard, it's just that it's detailed. Again, this is the easy table. Let me find the hard table. I'll get to the hard table in a minute because I've got it in here somewhere. Easy table. Already done those. Now, let me get to some more calculator problems. Just did that one and that one. That one's too easy. That one's the easy table. Now this shows you how to, if you were doing it by using the table, you would have to draw the picture like we do. You would have to find the z-score, which is data minus mean over standard deviation, to use the table to get your value. So it's not that it's that hard, but if you just type it in your calculator's going to give you the same exact answer. Here, you've got to draw the thing. Now, Krisha said, why do we have the smiley faces? For this problem, it said percentage of scores greater than 76. Well, I did 100 as my mean, 16 as my standard deviation, my data point was 76. So the first thing I had to figure out is how many spaces I was away. So I had to get my z-score. My z-score gave me a negative 1.5. So then I had to go to my table. table. Then I had to go to my table and find a z-score of negative 1.5. That 6.68% was to the left. I didn't want to the left, I wanted to the right. So the smiley faces told me where I wanted. So because I didn't want 6.68, I wanted that way, I had to subtract it from 100. You with me? Where the calculator will do all of that for you. It's not that it was that hard, but if we just type it into the calculator and tell it which way we want to go, that's why we do left and right. So we say, we want to go this way. The table always goes to the left, to the left, to the left, and we just say, hey, we want to go this way, and it goes that way. Let you do, I'm going to give you 3. Do those? Here, let's go to this one. Oh, we have none of those. I've got problems all mixed up in this one. Let's do normal distribution. Let's keep with the mean of 100 and the standard deviation of 16. Let's do these 3 to practice, and then we're going to do some real problems, word problems. There we go. I'm gonna get back to my page. Jamie, do we do these? Yeah. Okay. So you've got to draw the picture so that you can type it into your calculator correctly.
We did that last 114.
I'll mark that one off.
Thank you. I knew you were writing down everything I did. Let's see if I have another one. I'll just do those 2. Tori is here, EJ's here, Krisha's here, Amy is here, Jacob is not. Ray is not, Sue is here, Ariel is here. Thank you. Ashley is here, Tracy is here, Amber is not, Jada is not, Tanya is here, Heather is here, Jessica is not, Brittany is here, Jared is here, Jamie is here, Carlita is here, Calvin is here. Okay, so for attendance, 5 is good, correct? 1 to 5. 5 would be good for attendance, 1 to 5. I know, so it's a 1 to 5. So what do you want me to, oh, never mind, 5 is excellent. There's a legend right there. Hey, it would help if I read.
I don't know that you mad at me.
Okay, recommend for tutoring services? No.
Which one, Amy, I'll tutor some.
Grade me and make sure I get all things to do. All right, for the first one, we have a normal distribution, mean of 100, standard deviation of 16. Our data point is 76. 76 is less than 100, so 76 is going to be somewhere to the left of 100. It says greater than 76, so there's our shading. We're going to do the normal CDF, left, right, mean, standard deviation. Our left is where we started on the left, which is 76. Our right is where we ended up on the right, which is 999. Our mean is 100. Our standard deviation is 16. So I'm going to do second bars, normal CDF, 76, 999, 116. Not 116, but you know what I mean. So your answer should either be that or 93.32%. And we know it's going to be greater than 50% because more than half is shaded. All right. Come on. For this one, we have the mean, we said was 100. The standard deviation, we said was 16. This time we have two data points. 52 is going to be less than 100. 116 is going to be greater than 100. And we are shading between those 2 points. So, normal CDF, left, right, mean, standard deviation. So my left is where I started shading on my left, which was 52. My right is where I stopped shading on my right, which is 116. My mean is 100, and my standard deviation is 16. So second bars, normal CDF, oops, not normal PDF, but normal CDF. Second bars, normal CDF, and we're going to do 52, 116, 100, and then 16. And if that was rounded, it would be 84.00 or just 84. Yay? Easy peasy, as long as we don't have to use the table. All right, let's look at a real word problem. I love this one. I'm going to come around and look at it. You know enough to solve it. You just got to read it good. your normal curve with your mean and standard deviation, think about what your data point is, then think about your shading, do your normal CDF. I wanna know what percent of batteries get replaced under warranty, under the 36 months? What percent, Heather, get replaced under the 36 months with the charge? What percent of the people are gonna get a free battery? Got your shade. Yes, ma'am. Yes, ma'am. Yes, ma'am. Anything? Perfect. You had a tangent in there. When you taking the inverse tangent. Y'all ready for me? Y'all, they don't randomly say the car has a 10-year warranty or a 2-year warranty, or the drivetrain has a 5-year warranty, or the battery has a 46-month warranty. They don't randomly pick out those numbers. They do statistical analysis to pick out those numbers, okay? Because they don't want to give away free batteries. So if the batteries break down at 40 months, then they're going to give them 46, or if they batteries break down at 50 months, they're going to give it a 46-month. They don't want to give away free batteries. So this is saying normal distribution. The mean is 46 months. The standard deviation is 8 months. Are you with me so far? The only other number is 36. So that's our data point. 36 is to the left of 46 because it's smaller. Now, the question says, what percent of batteries under warranty? So that means if you walk into the store, the battery has a 36-month warranty. So we're doing under warranty, not under mean, under warranty. So if we came in and it was at 34 months, they would replace it, or 32 months, they would replace it, or 6 months, they would replace it. So we're doing less than 36 months. So we're going to do the normal CDF. My left is -999. My right is gonna be 36. My mean is gonna be 46. And my standard deviation is gonna be 8. So, second bars, normal CDF, negative 999 to 36, 46, and 8. So that means 10.56% of people get their battery replaced for free. So when people did this, most people's batteries died at 46 months. So we said, okay, we can't have a 48-month warranty because most people would get their battery for free. So we gotta make our warranty less than 46 months because we ain't giving batteries away. Y'all with me? All right, here's another good problem. This one was pretty cool. You can be too tall to be a Marine. They will kick you, they will not let you in the Marines for being too tall. That's what this one talks about.
Is that
Are you
true?
serious?
Or too short.
Is it true?
Mhm.
They do?
Mhm. Because if you're too tall, you can have a lot of health problems. And if you're too short, you can have a lot of health problems. So you have to be between 64 and 78 inches tall to go into the Marines. Mm-hmm. Surprised they haven't had discrimination lawsuits. I know. I'll be like, heck yeah, I can't go in there. Thank you.
What if they draft us with it?
I'm too old.
Me too.
I ain't worried.
Praise God, I think my son is just about to.
I have stepson that's 22, he's still,
Oh, yeah. What is it?
I don't know. He may be good. Just saying. My straight his butt.
That's his decision.
72, and 3 of the 8 people have made net A's, not hundreds, but net A's. All right. For this one, it says we have a normal distribution. The mean is 69. The standard deviation is 2.8. This time we have 2 data points. We have 64, which is to the left, and we have 78, which is to the right. And it says that we want to know what percent is between, or what percent can go to the Marines. So we want to do the normal CDF. So it's going to be left, comma, right, comma, mean, comma, standard deviation. So my left is going to be what?
64.
64. What is my right going to be? 78. What is my mean going to be? 69. What is my standard deviation going to be?
2.8.
2.8. So, second bars, normal CDF, 64, 78, 69, 2.8. So 96.23%. So 96.23% of, I think this was just men, of adult men can get into the Marines based on height. What percent cannot get into the Marines? How would I get that?
Subtract from 100.
Subtract from 100. So if I wanted to know what percent cannot, I would do 100 minus 96.23. So 3.77% cannot get in based on height. We good? Not bad. All right, next thing we're gonna learn. I know. No, I'm
It's
done
full.
learning. I'm learning.
It's
I'm
full.
done.
I have to throw
Okay.
something else out there.
If you take a picture of one person or 2 people, it is what it is. Okay? So 1 person or 2 people, it is what it is. So if you have 1 data point or 2 data points, it is what it is. That's what we've been doing. Now, if you take a picture of a bunch of people, so like at Easter time, or at Christmas, or whatever, if you just are taking a picture of you and your husband, or you, your husband, and your daughter, if there's only 1 or 2 or 3 people in the picture, it is what it is. If you're fat, if you're short, if you're tall, you can't hide. But if you put a bunch of people in a picture, I love taking pictures with a bunch of people. Because the photographer will say, scooch in, and I'm like, oh yeah, Madison comes stand in front of me, so that all you see is like my face, okay? So if you put a bunch of people in there, they start looking skinny. The more people you put in there, the skinnier they look, okay? So the bigger the group, the more the people, the smaller they get, the skinnier they look, and the smaller the deviation, the smaller the size. So here, if I have, a person that's 300 pounds, let's say the standard deviation is 300. The jump size is 300. And I put that same 300-pound person in their high school reunion group, they may look like they're 50 pounds because there's so many people around them you can't see much of them. You with me? So the more people, the skinnier they are, the smaller their standard deviation. So when you put people in a group, what's going to change is the size of the person. I mean, if I put enough people in there, they're going to look like ants. If you put 1,000 people in there, they're going to look teeny tiny. You're going to say, where am I? All I remember is where I was standing, okay? So that's what we're going to be doing in this. We're going to be dealing with individual data, and we're going to be dealing with group data. And y'all, if you ever, I always love saying, let's go take a group picture, we're gonna make a normal distribution. Because when you make a normal distribution, when you make a group picture, what do? You put the tall people in the back,
Yeah.
and then it kind of goes out. So now, when you look at family pictures, it's a normal distribution.